Fabrication of the nMOS transistor. The process starts with the oxidation of silicon substrate, figure A, in which a relatively thick silicon dioxide layer, also called field oxide, is created on the surface. On the surface, figure B, then the field oxide is selectively etched to expose the silicon surface on which the MOS transistor will be created. Figure C. Following this step, the surface is covered with a thin, high-quality oxide layer which will eventually form the gate oxide of the MOS transistor. Figure D. On the top of the silicon oxide layer, a layer of polysilicon crystalline silicon is deposited. Figure E. Polysilicon is used both as gate electrode material for MOS transistor and also as an interconnect medium. In here you can see the figure process flow for the fabrication of an N-type MOSFET on E-type silicon. Silicon integrated circuits. Undoped polysilicon has relatively high resistivity. The resistivity of polysilicon can be reduced, however, by doping it with impurity atoms. After deposition, the polysilicon layer is patterned and etched to form the interconnects and the MOS transistor gates. Figure F. The thin gate oxide not covered by polysilicon is also etched away, which exposes the bare silicon surface on which the source and the drain junctions are to be formed. Figure G. The entire silicon surface is doped with a high concentration of impurities, either through diffusion or ion implantation, in this case with donor atoms, to produce N-type doping. Figure H, creating two N-type regions, source and drain junctions in the P-type substrate. The impurity doping also penetrates the polysilicon on the surface, reducing its resistivity. Note that the polysilicon gate, which is patterned before doping, actually defines the precise location of the channel region and hence the location of the source and the drain regions. Since its procedure allows very precise positioning of the two regions relative to the gate, it is also called the self-aligned process. Once the source and drain regions are completed, the entire surface is again covered with an insulating layer of silicon dioxide. Figure I. The insulating oxide layer is then patterned in order to provide contact windows for the drain and the source junctions. Figure J. The surface is covered with evaporated aluminum, which will form the interconnects. Figure F. Finally, the metal layer is patterned and etched, completing the interconnection of the MOS transistors on the surface. Figure I. Usually the second and third layer of metallic interconnect can also be added on top of this structure by creating another insulating oxide layer, cutting contact via holes, depositing and patenting the metal. The major process steps for the fabrication of an nMOS transistor on P-type silicon substrate are also illustrated on plate 1 and plate 2 on pages 75 to 76. The figures were generated using DIOS multidimensional process simulator, a process simulation where a process simulation software by ISC Integrated Systems Engineering AG Zurich, Switzerland. Thank you.